students, we are solving the IB Math EA AGL past papers, and currently we are solving the IB Math EA AGL November 2021 paper 2. And today we will be solving question number 10 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in my channel. So without any further delay, let us start answering question number 10. The maximum mark is 18. Consider the function f of x equal to x squared minus x minus 12 over 2x minus 15, where x belongs to the set of real numbers and x is not equal to 15 over 2. So part A is find the coordinates. No, coordinates. That means you have to give both the x coordinate and the y coordinate, where the graph of f crosses the x-axis. I is the x-axis and I is the y-axis. Okay, fine. And it contains 3 marks. Where the graph crosses the x-axis means those are referred to as the zeros or the x-intercepts. And this is the y-intercept. So for these points where the graph crosses the x-axis, at those points, in fact, for every value, every point on the x-axis, the y-coordinate is equal to 0. So therefore, the points where the graph crosses the x-axis, for those points also, the y-coordinate should be equal to 0 or f of x should be equal to 0. So 0 is equal to x squared minus x minus 12 over 2x minus 15. And since the value of a fraction is equal to 0, therefore the numerator should be equal to 0. So x squared minus x minus 12 should be equal to 0, and I should be factorizing this left side. So this will be x minus and x. This is minus x and minus 12. So it is 4 and 3 because it is minus x. So it should be x minus 4 and x plus 3. You may factorize it using the middle term. This is also using the middle term splitting method. So I have just done it in one step. You may do it in elaborate form. Just don't make any mistake. So therefore, the points will be 4, 0 and negative 3, 0. Okay. Coming to y axis, where the x coordinate will be equal to 0. So it should be f of x or y is equal to 0 minus 0 square minus 0 minus 12 over 2 times 0 minus 15. So these two will be getting cancelled, 12 over 15. So if I divide the numerator and the denominator by 3, it gives us 4 over 5. Okay. So the point is 0, 4 over 5. 3 times 4 is 12 and 3 times 5 is 15. So we have given the answer for the I and the II. Now we are coming to the subpart B. Okay. Write down the equation of the vertical asymptote. The vertical asymptote, for that we need to equate the denominator to 0. Fine. So 2x minus 15 is equal to 0, which gives us the equation as x equal to 15 over 2. Okay. So this is the vertical asymptote. That is why they have written x is not equal to 15 over 2. Because when x equal to 15 over 2, the function is non-existent at that point. This is the vertical asymptote. This is the equation. Don't write x is not equal to 15 over 2. That is written when the function is defined. But when you are writing the equation of the vertical asymptote, it is x equal to 15 over 2. Okay. Now coming to subpart C. The oblique asymptote. Okay. The oblique asymptote of the graph of f can be written as y equals ax plus b, where a and b belongs to the set of rational numbers. Find the value of a and the value of b. For getting the equation of the oblique asymptote, what do? We divide the numerator by the denominator. When do we get an oblique asymptote for a function? When the degree of the numerator, it should be a rational function, and the degree of the numerator should be greater than the degree of the denominator. Over here, the degree of the numerator, it is a quadratic expression, so the degree is 2. Whereas the degree of the denominator, it is a linear expression, so its degree is 1. So the degree of the denominator expression is more than that of the degree of the numerator is more than that of the denominator. So we will be having an oblique asymptote for this function. Okay, and we will be dividing the numerator by the denominator expression. Okay, so let us do that. Fine. It is 2x minus 15 and x square minus x minus 12. Fine. To get the first term of the quotient, what do? We divide the first term of the dividend by the first term of the divisor. So this is the rough part. So first term of the dividend is x square. I am dividing this by the first term of the divisor, which is 2x. So we get the first term of the quotient as x over 2. We write that. Okay. And you can in fact get the equation in various ways. I am performing the algebraic long division. So x over 2. Next, you multiply this term, the first term of the quotient, with every term of the divisor. And you write the terms that you are getting, the products, under the like terms. So x over 2 times 2x will be x square. I am writing this under x square. Next is x over 2 times negative 15. It will be negative 15x over 2. Negative 15x over 2. Okay. And then we will be subtracting, so the signs will be changing. These two will be getting cancelled, and this will be 15x over 2 minus x. So let us do this over here. So 15x over 2 minus x. So minus, I can write this as minus 2x over 2, which is equal to x. Okay. I'm just making the denominators the same. So in place of x, I am writing minus 2x over 2. So this is 13x over 2. 15 minus 2 is 13. So it is 13x over 2. And I bring down the minus 12. And next again, I will be, this becomes the first term of the dividend. Now this is the dividend, this is the divisor. So this is the first term of the dividend. And this is 13x over 2. This should get divided by 2x. Okay. So this is 13x over 2 times by 1 over 2x. So these two will be getting cancelled and we will be having the next term of the quotient as 13 over 4. Okay. So it is 13 over 4 plus 13 over 4. Okay. And next again we will be multiplying 31 over 4 with this 2x and minus 15. So this will be 13 over 4 times 2x will be 13x over 2. So this is 13x over 2. And 13 over 4 minus 15 is equal to 13 minus 13 times 15 is what we have to find out. So 13 times 15 is equal to 195. So it will be negative 195 over 4. But we do not need this because we do not need the remainder. We only need the quotient. Okay. So this is the equation of the oblique asymptote. Therefore, hope it is, yeah. This is the equation of the oblique asymptote. Therefore, the oblique asymptote should be written as y equals x over 2, or I'm writing half x plus 13 over 4. Okay. Therefore, a is equal to half, b is equal to 13 over 4. I hope you are being able to see this line. I sincerely hope that. Okay. So we have given the values of A and B, and we have also given the equation of the oblique asymptote y equals x over 2 or half x plus 13 over 4, which is 13 over 4 is 12 over 4 is 3. So 3 and 1 over 4, that is 3.25. Fine, but anyway, we have given the equation as well as we have given the A and B values. These are indeed two rational numbers. Let us move on to the next subpart. Subpart D, sketch the graph of f for x ranging between negative 30 and positive 30, both included, clearly indicating the points of intersection with each axis and any asymptotes, and it contains 3 marks. This is the function expression, and these two are the two x-intercepts. This is the y-intercept. This is the equation of the vertical asymptote x equal to 15 over 2 or 7.5. And this is the equation of the oblique asymptote y equals x over 2 or half x plus 13 over 4 or 3 and 1 over 4. That is 3.25. Okay. So these things we know, and I have just drawn the two axes and the two asymptotes. So this one is the x equal to 15 over 2 asymptote, vertical asymptote, and this one is the y equals x over 2 plus 13 over 4. Okay. 13 over 4 will be the y-intercept of this line. That is 3.25. So this line is passing through this point, roughly equal to 3.25, and this is roughly equal to 7.5, which is 15 over 2. And the x-intercept of this line will be when y equals 0, x over 2 will be negative 13 over 4. Okay, let me just do it over here. 0 equal to x over 2 plus 13 over 4. So x over 2 equal to negative 13 over 4 and x equal to negative 13 over 4 times 2. So it is negative 13 over 2, which is the negative 6.5. So it is passing to this point. Okay. And of course, it is paper 2. You will be using the calculator. You can see the shape of the graph. You have to copy it correctly. Okay. So we will be graphing this expression. Let us go to the graph part first of all. And it is x square minus x minus 12 over 2x minus 15. Enter. And we need between negative 30 to positive 30. And since they have given the x value ranging between negative 30 to positive 30, I have taken the y values also from negative 30 to positive 30. Okay. Come over here and go to the graph settings. So window settings, it will be negative 30 to positive 30. And this also negative 30 to positive 30. Okay. Okay, fine. So you are seeing you are not seeing the oblique asymptote. Let us draw them as well. If you want, I can draw them. Fine. So tab, it is one will be the vertical asymptote is x equal to 7.5. But first of all, let me get the oblique asymptote. X over 2. So x divided by 2 plus 13 over 4. Enter. They have taken the equation correctly. X over 2 plus 13 over 4. See, this is the oblique asymptote. And another one, we have to sketch the vertical line x equal to 15 over 2. If you want, we may get that as well. Okay. Function, equation templates, lines, vertical line, x equal to 15 over 2. So this is the x equal to 15 over 2. Okay. Now, in case if you want to get the local maximum and the local minimum points of the graph, we can go to the analyze graph and maximum. They are asking for which graph? Lower bound, upper bound. So this is the maximum point. Let me take it over here. Okay, and the minimum. Analyze graph, minimum. Which graph? Again, this one. This is the minimum point. Okay. So, is it the minimum point? Let me try once more. Minimum, which graph? This one. Yeah, it is the same thing. Okay. 15.56, sorry, 13.5622. So 13.5 and this is also 13.06. So let me first of all mark the minimum point since I have read this first of all. 13 point, I'm taking 13.6 and this is 13. So 13.6 and 13 should be the minimum point and this one is 12. 13.6 maybe over here, and 13 maybe over here, somewhere over here. You don't have to be accurate, but you should be, the graph should be uh, more or less showing the every detail, every important aspect. So I'm plotting the point over here. And the maximum is 1.4, 1.4. So it is 1.4, doesn't matter if it is 1.4 or 1.5, we cannot be that accurate. And 0.9, so almost 1, and 1.4 and 1. 1.4 and 1. This one is the y-intercept was equal to, the y-intercept was 4 over 5. It was not equal to 1, so it will be moving up. So 1.4 and 1 maybe over here, slightly above. Okay, so now we are in a position to sketch the graph, I think. Let us try. So it will be this way. This is the graph, and this will be this way. Somewhat of this type. Okay. So this is the graph of f of x equal to x square minus x minus 12 over 2x minus 15. Okay. So we have completed, and if you want, you may write these. So this one is 40. This one is minus 30, and this one is 0 and 4 over 5. You may write these important points, coordinates. Okay. So we are done with the graph. Let us move on to the next sapati. Sapati, it contains two more saparts. The I sapat is express 1 over f of x in partial fractions, where f of x is this one. Okay. So, okay, let us start answering. So 1 over f of x, the reciprocal, will be equal to 2x minus 15 over x square minus x minus 12, which can be, I have to now factorize the denominator. So 2x minus 15 over x minus 4 and x plus 3. We had factorized this right at the beginning of this question once, for Sapat A most probably. You can factorize it once more if you want. This is minus 12 and this is minus x. So 4 and 3 will be the two factors. And since we need a minus x, so it will be minus 4x plus 3x. So it is minus 4 and plus 3. Okay? Minus 4 times plus 3 will be giving you minus 12, and minus 4x plus 3x will be giving you minus 6. So the factors, the two linear factors are x minus 4 and x plus 3. So this should be written as, because we have to express this in partial fractions, this should be equal to a over x minus 4 plus b over x plus 3. Okay. Now we have to get the values of a and b. So we take this equation and we multiply this entire equation by this denominator x minus 4 times x plus 3. So we get 2x minus 15 is equal to a times x plus 3, because when this term is multiplied by x minus 4 times x plus 3, this x minus 4 and this x minus 4, they will be getting cancelled. So we will be having a times x plus 3 plus b times, using the similar logic, b times x minus 4. Okay. Therefore, when x equal to 4, the left hand side is 2 times 4 is 8. 8 minus 15. 8 minus 15 is minus 7. Okay. Is equal to e equal to 4. Sorry, x equal to 4. 4 plus 3 is 7, equal to 7e. And this is 4 minus 4 is 0. 0 times b is 0. Okay. So negative 7 equal to 7e. Therefore, e is equal to negative 1. Okay. And when x equal to negative 3, 2 times negative 3 is negative 6. Negative 6, negative 15 is negative 21. Equal to negative 3, positive 3. Add it, gives us a 0. A times 0 is 0, and this is b times negative 3, negative 4. So it is negative 7. Negative 7b. Okay. So the b value is 3. So now we will be writing this as the answer will be, this will be equal to, therefore, partial fractions equal to, in place of a, I'll be writing negative 1 over x minus 4, and for b, I will be writing 3 over x plus 3. Okay. So this is the answer for the subpart I. And now we come to II. Hence, find the exact value of, this is 0 to 3. This is a definite integration. 1 over f of x with respect to x, we are integrating, expressing your answer as a single logarithm. So in place of 1 over f of x expression, that is this one, we will be using this expression. Okay. So this will be in fact 0 to 3 minus 1 over x minus 4 plus 3 over x plus 3 dx, which is, I can take out the minus sign, it is 0 to 3, 1 over x minus 4 dx plus, I can take out the 3 as well. So it is 1 over x plus 3 dx. The boundary values will be 0 and 3. And now we have to integrate, and these are very easy integrations, so I'll not be substituting. These will be just the logs. So it will be equal to negative ln of x minus 4 plus 3 times ln of x plus 3. So this is minus ln of, when x equal to 3, 3 minus 4 is negative 1. So ln of modulus of negative 1 is positive 1. So it is 1 minus, when x equal to 0, it is ln of negative 4, positive, absolute value of negative 4 is positive 4. So it is ln of positive 4 plus 3 ln of, when x equal to 3, 3 plus 3 is 6. And when x equal to 0, it is minus ln of 3. Okay. So this is actually equal to, ln of 1 is 0. So minus of minus is plus, so ln of 4. And this one is plus 3 times ln of 6 divided by 3, which is 2. Because it is ln of 6 minus ln of 3, it is ln of 6 over 3, which is 2. So this is ln of 4 plus 3 times ln of 2. Okay, and this is ln of 2, this is ln of 4. We have to give the answer as a single logarithm. So I'm writing this as ln of 2 square plus, or I'm just taking this as 2 ln of 2. In place of 4, I am writing 2 ln of 2. And this is 3 ln of 2, which is equal to 5 ln of 2. Okay, 5 times ln of 2. So this is the answer. This is the answer for the subpart II. And so we have completed solving question number 10. And I am Nilanjana Sanyal. I'm an online IB Math ASL and HL tutor. I tutor students from both within India and outside India. And right now I am solving the IB Math HL past papers and posting them as videos in my YouTube channel. As you are seeing, in case you are liking my explanations, please do give these videos some likes, and please do share these videos with your friends so that even they get benefited by watching these videos. And if you have anything to suggest, or if you have any other question in your mind, you please feel free to write to me in the comment section. And please do subscribe to my YouTube channel. It will be motivating me to make more math videos for you. And thank you for staying with me till the end. We meet again in our next session very soon, where I'll be solving question number 11 of the same paper. So till then, bye.